So in this video, we're going to talk about special right triangles, and I'm actually going to show you a trick using tables to help solve for these. Okay, so one of the special triangles is a 45, 45, 90. With that 45, 45, 90, this is actually a isosceles triangle because we have two congruent angles, okay? And when we have two congruent angles, it means that we have two congruent sides. So this is a special triangle because it has a pattern. Every single 45, 45, 90 triangle, right triangle, is going to have this pattern. It's going to have an x radical 2. So in this case, if we had it to be 5, it means that if this side is 5, we know this side is 5 because it's isosceles, and we know that this is going to be 5 radical 2. How do I know that? Because of the pattern, okay? So 5, 5, 5 radical 2. If this was 10 radical 2, then this would be 10, this would be 10, and so on, all right? But sometimes these numbers aren't as nice as I just made them out to be. Sometimes these numbers are like 30. Okay, well, how do we get from 30, how do we get to this side? Well, this is where this table comes in, okay? And this table is just helping us come up with these proportions. And how we use this table is we input numbers here that are across from our angles, okay? So for example, if the hypotenuse was 30, well, that's across from 90, so 30 would go here, our x would go here, and then look, we have proportions. You just solve for proportions in that way, okay? The 30, 60, 90 table is very similar. Again, we have a 30, 60, 90 triangle here. The x, the 1 is always across from the 30, and the 2 is always across from the 90, 2x. And then this, the radical 3, the x radical 3 would be across from the 60. These actually go in numeric order, okay? 1, radical 3, 2. Radical 3 is, I forget what the decimal is, but it's in between 1 and 2. So these tables go in numeric order, 30, 60, 90, 1, radical 3, 2. So they're not really that hard to memorize, and they really, really help us out when we're trying to find the sides of the triangle, okay? So let's go ahead and do some examples here. So again, with this 45, 45, 90, the legs would be our x, and our hypotenuse would be x radical 2. All right, this is an easy one, okay, because one of my legs is 8. So across from the 45, I have 8. Across from the other 45 would be 8, or it's going to be 8, but I'll tell you why in a second. It's going to be my x, and then across from the 90 is going to be my y, because we're trying to find both of those situations, okay? So in this case, we would solve both proportions. So we would have 8 over 1 is equal to x over 1. Well, anything over 1 is kind of irrelevant, okay? We don't really have to write that in, so we can just kind of drop those, and we would have 8 is equal to x. So we know that x is going to be equal to 8, okay? And then for our y, we're going to use the proportion that we already know, okay? Because we don't want to mess anything up. We don't want it, like if we mess something up with x, we don't want to use that messed up number. So always go back to what you know. So 8 over 1, that's going to be equal to y over radical 2. And then again, you would just cross multiply. 1 times y is y. 8 times radical 2 would be 8 radical 2. And that right there would be our answer, okay? That one is a simple one. Let's see if these get any harder. This one is actually a simple one as well. Okay, so again, we have 25 here, we have y, and we have x. So if we solve, we get 25 over 1 is equal to y over 1. Again, anything over 1 is going to just be itself. So we get 25 for y. And then again, set up our proportions. Cross multiply, I get x is equal to 25 radical 2. Okay. So here's one that's a little bit more difficult and why the table is so helpful. Okay. So they give us the hypotenuse this time. They give us 19. So 19 is going to go across from the radical 2, and then x and y are going to be here. Now x and y are actually going to be equal. Okay. So we don't necessarily need to do both of them. Why are they going to be equal? Again, it's an isosceles triangle. X is going to be equal to y. Okay, so let's go ahead and set up our proportion. We have y over 1 is equal to 19 over radical 2. So we cross multiply here. I get 19 is equal to y radical 2. Now to get y by itself, I'm going to have divide here. So I get y is equal to 19 over radical 2. However, if you recall, we can't have a denominator in the, we can't have a radical in the denominator, okay? That's not going to help us. That's not going to work. So what we need to do is we need to rationalize, which means that we're going to be multiplying by whatever's in the denominator. So I'm going to multiply by radical 2 over radical 2. So in the top, I'm going to get 19 radical 2. And in the denominator, all right, remember, this is what happens here. We get radical 2 times radical 2, which is radical 4. Well, the square root of 4 is 2. So ultimately, what's happening is the radicals canceling. So we're going to have 19 radical 2 over 2. And then 19 divided by 2 doesn't simplify. So that right there is going to be my answer for x and y. Okay, so this is a perfect example of why using this table is super helpful. Okay, so let's do some examples with the 30, 60, 90. So again, the angles that are across from, that's what you're going to be inputting. So across from the 30 is the 1x. Across from the 60 is the radical 3, and then across from the hypotenuse is the 2. So let's go ahead and fill this table in. So across from the 30, now 30 is not written here. You can write it in here if you want. But across from the 30 is 5. Okay, across from the 60 is x, and then across from the 90 is y. Now remember, you can only solve for one at a time. Don't try to, I don't even know how you do a proportion all three at once. That's not going to work. So let's go ahead and try this one. So we have 5 over 1 is equal to x over radical 3. When we cross multiply, we get x is 5 radical 3. Okay, there's our one answer. And then again, we want to keep going from the one that we have, okay? So we have 5 over 1 is equal to y over 2. Cross multiply, and I get y is equal to 10. So this was an easier one, but see how the table is very helpful with this. All right. Okay. That one's going to be a similar one as well. Okay, so let's go ahead and look at this one. So we have 32 is across from the 90. And then the x goes across from the 30. And the y is going to go across from the 60 again. That's going to go there. Okay, so let's go ahead and set up our proportions. I have y over radical 3 is equal to 32 over 2. Cross multiply. 2y is equal to 32 radical 3. Divide by 2. Okay, and I get y is equal to 16 radical 3. So that would be my answer for the y. Okay, and then for the x, I get x over 1 is equal to 32 over 2. If I cross multiply, I get 2x is equal to 32. Whoa. Going ahead of myself here. Divide by 2, and I get x is equal to 16. So x is 16, and y is 16 radical 3. Okay? So again, using that table is helpful. So let's go ahead and do this example. Actually, no, let's not do this one. Let's do this one. Number 8. Okay, so again, the 30 goes up here. So across from the 60 is going to be 20. Across from the 90 is x, and across from the 30 is y. All right, so let's go ahead and work through this. Let's do this first one first. So we have y over 1 is equal to 20 over radical 3. And when we cross multiply, we're going to get y radical 3 is equal to 20. And again, we're going to divide by radical 3. I get y is equal to 20 over radical 3. Okay, problem here. Can't have that radical in the denominator. So we're just going to rationalize real quick. Really easy to rationalize. Okay, so we get 20 radical 3 in the top. Okay, just recall, I'm going to do a quick little thing up here. Remember, radical 3 times radical 3 is radical 9, which the square root of 9 is just 3. So ultimately, the radicals just cancel, so I get 3 in the denominator. And then 20 divided by 3 is not a nice number, so we're going to leave it as that. So y is going to be 20 radical 3 over 3. So let's go ahead and do x. So x, we're going to have 20 radical 3 over radical 3 is equal to x over 2. Okay, so cross multiply. X radical 3 is equal to 20 times 2 is 40. Again, divide by radical 3. I get x is equal to 40 over radical 3. Not okay. Rationalize. So I'm going to get 40 radical 3 over 3 for x. And again, if the fraction's simplified, you would want to simplify them, but those in that case do not simplify. Okay? And that's how you do it.